In this module, Module 3.5, we will be looking at the simple exercise of sorting data, and we'll take this opportunity to point out a few interesting insights within stock market data. And so we're going to illustrate some R code to sort the data, very simple, but we're also going to look at daily first differences. You can think of this as dollar profits and losses per share on a particular stock. Daily percentage rates of return. And we're going to look at some selected insights that come about from this data that most quantitative analysts have never really thought about, and particularly the influence of 1-cent trading increments. And so the R code, if you read in a set of data, this is a set of observations between 0 and 100 that is stored in sortingdata.dat. If you just look at the first 5 observations and the last 5 observations, it's just random numbers between 1 and 100 or 0 and 100. And so we can compute the number of observations. We can, the key function here is sorting the data, and we can check to be sure that the data is in fact sorted. And the first 5 observations are the lowest numbers, the last 5 observations are the highest. No really big insights here. You just need to learn what the different functions that are available in Bayes are and different ways of sorting. Well, let's look at some data from Southern Company stock, and we're going to examine dollar first differences, which is simply the dollar price change today versus yesterday, and these are closing prices. So if this is today's closing price, this would be the last trading day's closing price, and that would simply be the dollar first difference. We could also compute the percentage change. This is a discretely compounded percentage change. We take the dollar first difference and then divide it by the initial price or the investment, and we get the percentage change. And we'll look at different observations on price level and the influence of trading increments. Before we get there, if we take data from, let's say, 1997 through 2020, what we observe is the mean is slightly positive on first differences. Standard deviation is about 39 cents, and there's positive skewness. So if this were in fact the normally distributed variable, we would expect this skewness to be close to 0. And so this is an illustration of first differences. The histogram is what's actually there. The bell-shaped curve is based on the sample mean and sample standard deviation. If we look at percentage rates of return, we see that the mean is about 5 basis points. Standard deviation is 1.3% roughly. And again, we have this positive skewness. You can sort of see this positive skewness in this histogram. If we fit a normally distributed variable to the mean and standard deviation, we get this kind of a shape of a curve. And so actual financial data tends to have more observations in the extreme than what the normal distribution permits. And often there is significant positive or negative skewness. What this graph depicts, this is just the price over this period of time. Southern Company has enjoyed quite a bit of an increase in its share price over this window of time. And so the average share price is between 20 and 30, but the actual price going up. And so if you look at dollar first differences, you'll notice that the volatility of these first differences is very low when the price is low. We then notice that when the price is high, the volatility begins to increase. Now, this makes intuitive sense that 1% move in a $50 price is much greater than a 1% move in a $5 price. So the first observation is as the share price increases, we would expect the first difference to become more volatile. The second thing to notice in the great financial crisis of 2008-2009, there was an increase in volatility of Southern Company stock, and then with the onset of the pandemic, we had the same sort of spike in volatility. So one important insight is that volatility itself is volatile, and especially during times of great stress. What we observe in the figure of percentage changes is that this pattern of increasing volatility with the price goes away. And so we can see much more clearly that in times of crisis, we have higher volatility in the great financial crisis as well as during the pandemic. And then there are seasons of time when the volatility is quite low. And so it's an important insight in understanding financial data is that volatility itself is not constant. It is in fact changing over time. And good investment managers or quantitative financial analysts can incorporate this changing volatility in their analysis. If we look under a microscope, this first difference, and we look at just minus 5 cents to plus 5 cents, what we notice, there's a couple things to notice in this chart, is that first differences only exist on the pennies. And so that's the first observation, is that prices are discrete, and they're discrete to the penny. The second observation is that there appears to be way more 0 and plus ones than anything else. And this has to do with holidays. A holiday, the first difference, because I'm using what's known as a forward field methodology in my data sets, holidays result in a 0 first difference. And then with percentage changes, we see that this pattern is not near as clear, but there is a pattern there, and that pattern is reflecting the 1 cent moves that are available. And so it's important that when you're working with this kind of data that you understand some of the nuances. So in summary, we simply began working with sorting data. We demonstrated the difference between first differences and percentage rates of return. And we looked at some selected insights, primarily the influence of 1 cent trading. We turn now to look at some of the R code related to this module. So this particular source code is very, very simple. There's just a PRN file, a DAT file, and one single R program, test program. And so this particular program doesn't do a whole lot. Generate some of the graphs we just looked at previously. And so depending on how I left it, there's nothing in the environment, so I don't need to worry about that. And so working through this particular package, I'm going to be using some statistical moments and data.table and date, perhaps. And so the data is stored, one form of the data is stored in a DAT file. And so if I read this in, I can just look at what this data is. It's simply a vector of 100 observations sorted. And so again, what's the first 5 observations, the last 5, how many observations are there? If you'll notice, there's 100. And so I create a vector and I place that those observations into that data vector. I can then simply sort it using the sort command. If I don't remember which package the sort command is in, I can go to the help, type in sort, and it will tell me that it's in the base package, and it'll give me some clues on how to use it. And so if I run this sort, the data vector sorted is now in ascending order, and I could look at the first 5 or the last 5 observations in this particular data set. And so I used to use a data service known as CSI. The Southern Company data came from there. Basically, give me all the data that's available on Southern Company. And so the sort data now has 6,302 observations. There's 26 different variables coming out of that data set, most of which I'm not going to use. What are all these different things? And I can sort by, sort the data by, I can trim the data, by the upper or lower dates provided. There's not going to be any trimming. This keeps is actually a really good function. All I really want, I don't need all these different variables. all I want to keep is the date and the close. And so if you'll notice, the sorted data has 26 variables. If I set a vector called keeps, date and close, and then I apply that, if I convert the sorted data to a data frame, and then I say, listen, all I want to do is keep those two variables. Sorted data now contain just the closing price and the date. Notice this date is an unusual format of year, month, day with no dashes or slashes or anything. And so I can look at what that data shows. And I can, because of the unusual nature of those dates, I can do all sorts of creating different date variables: the year, the month, the day, the character date, the Julian number, and just in case I need to do some management of dates. And so I can now look at the different variables that are available. I can calculate the length, the start date, and the end date. And I can add a couple of variables to sort data: the first difference in return, fill them with the N not available, or NA. So if you'll notice, I now have 9 variables in this particular data frame. First difference in returns have been filled in with NA. And then when I run this calculation, the data now contains first differences in returns. And I can do all kinds of analysis. Whenever you do calculate returns or first differences, you lose that first observation. And so I'm going to go ahead and trim that out so that it doesn't cause calculation problems in the future. I can compute a variety of different variables, and then I'm ready to run some plots. And in this particular case, generates the histogram as well as the standard normal distribution based on the sample parameters. I can, this is the daily first differences. I can run and calculate the daily rates of return, and then I could compute the prices, the price series. And so clearly, as the prices have gone up, as we mentioned before, we would expect that the first differences to become more volatile, and in fact they do. And so first differences are not stable, they're price sensitive. Rates of return are much more stable, and percentage changes, but we do notice that the volatility is itself volatile. Southern Company, for whatever reason, in the 2001 range, this was sort of when Enron blew up, and there's a lot of different things going on. Southern Company was much more risky than post-Enron, and it became a much larger company over time, and so it's internally diversified. We examine first differences. You can do some calculations and set the y-axis in order to see the decimalization and its influence on how first differences behave. We do see the influence of this decimalization in the price data, but over time it becomes less and less apparent. And so, and again, we have way more zero observations, and that has more to do with forward fill and how the data is managed than actual zero observations itself. And so that's basically sorting, not a really profound insight, but it will be a tool that will be useful for many quantitative finance tasks.